So welcome to the EANTC multi-vendor interoperability booth again. Now we have a demo of the SDN transport slicing, where we'll see multiple orchestrators and routers working together nicely to create and visualize network slices. Pretty innovative demo, so I'm very happy to hand over the microphone to Sujay Murthy from Cisco, who is going to kick it off, and then hand over to other vendors as well. Go ahead.
Yeah, hey, thanks, Carsten. So hello everyone. So we'll cover the SDN transport slicing demo as part of EANTC showcase. This demo was predominantly tested with all the vendors that operated with NetConf in the EANTC testing. So the vendors like Ciena, Huawei, Cisco, Ericsson, Juniper, and we used Keysight for the end-to-end traffic generation. So what the test case purpose was is to orchestrate and visualize a multi-vendor transport slice using the IETF network slice NBI YANG model. The objective from that YANG model was to look at how can an operator prepare for a slice, transport slice, commissioning of a transport slice service, and visualizing the transport slice intent with the traffic engineering policies that is enabled. The vendor nodes like Cisco, Ciena, Huawei, Ericsson, and Juniper were acting as all the PE endpoints in the nodes, and the CNC or the crosswalk network controller was acting as the orchestrator or the controller for slice manager. So what is the network slice YANG, the NBI slice YANG? It's aligning with what the 3GPP architecture defines, that you have an end-to-end orchestrator, which is the NSMF, and then you are having subdomain or the domain level specific orchestrator or controllers, which is the NSSMF, that do the orchestration and management of the slice for the respective domains. So for this test, we did focus on the NSSMF, which is the transport NSSMF, talking to multi-vendor node and devices. So for the EANTC test results, you see here that the transport NSSMF is the Cisco's network crosswalk network controller, followed by the vendor nodes that are acting as PEs and the Keysight connected to generate the traffic. We also have like the PSEP session across all the nodes talking to PCEs, and then discovered the topology through crosswalk network controller. So the EANTC test procedure covered these steps. That is, how do you prepare those SLO and SLE templates using the northbound integration YANG, commissioning of a transport slice service, that is the intent of your slice, to create a layer 3 VPNs with a slice transport intent for segment routing policies, then visualizing those transport slice services, and also visualizing the traffic engineering policies that are associated to those VPN service. Finally, the end-to-end validation test through Keysight, generating layer 3 traffic across the nodes. So for this demo, for today's presentation and demo, we look at the topology that we have here connected. This is the topology that we also use for the EANTC interop testing. So here the green nodes are the PE nodes that are connected to some of the nodes connected to Keysight to do the PC neighbor relationship, and then other routers have peering with other BGP AS. So we'll use the Cisco's controller to orchestrate a slice service across these nodes and endpoints. So as part of today's demo, we'll look at how the SLO SLE templates are created or what they look like, and then we'll also look at the slice service that was already commissioned. That is, we have a layer 3 VPN with traffic engineering tunnels and policies already enabled. We'll visualize the transport slice service and look at the traffic engineering paths for those policies and validate the traffic through Keysight. So let me switch my screen. All right, so this is the dashboard pane for the crosswalk network controller, where you can see that there is a summary view of all the different types of services, traffic engineering policies, topology information, and device status information. We'll start with the topology. So for this test, we've discovered, let me change the view to something nicer. So we've discovered this topology through SRPC, through the BGP link state. And as you can see, this topology comprises of Cisco, Juniper, Ciena, Huawei, Nokia, and Ericsson. And on the right-hand side, we can see the device information for each of the vendors that has been added into NSO, discovered through the topology, and enabled with PSAP connection to SRPC on Cisco's nodes. So for example, I can click on the Huawei node here to see what is the summary, the product type, the T router IDs, and also we can look at the links. These are the various ISIS links that is discovered as part of the topology. So for example, between Huawei and MX204, I can click on the specific link, look at what is the interface stats, the metric information, like the delay metric that is also collected from the device is visualized here as part of the link details. Likewise, on the network devices, you can see a whole lot more information on what is the state for the device, what is the configuration, and for example, I'll go to the similar Huawei device here to see what is the product type and the family and the software type or the version for any vendor. I can click between Huawei and let's say for Ciena, on the Ciena's type, what is the host name and the inventory ID information, and the T router ID information for every vendor. So I'll jump into what we look at the slice template catalog. The slice template catalog follows the NBI-YANG structure of how a user can create the catalog and define the intent through what is the forwarding plane definition, like what type of policy does he want. So for example, in this case, I'm looking at EMBB or a URLLC type of a slice. I can define what is the forwarding plane policy that this catalog can be used. So I'm using a color ID with a specific metric to say that I need this intent when I provision a slice. And you define the QoS for your edge nodes on the Ps that are connecting towards Cs to say what are the QoS policies to be applied on the interface. And for layer 2 and layer 3s, you can define your set of QoS policies through the catalog. So moving on to the transport slice service. So this is the service that is already orchestrated. So we are looking at a slice E. Let me switch to this view. And I can see that I already have a slice that is provisioned across these nodes between one on Huawei, Juniper, Ciena, Cisco, and Ericsson. And I can see that this is using an NSST template, which is no cause binding for now. We look at the view details. So this tells me what is the slice ID for which customer, the service type, which is a layer 3 type of a slice. The NSST template, that is through the catalog, we see what are the parameters that this catalog is invoking for this slice. Now I don't have QoS, so there are no QoS parameters, but I can see what is a forwarding plane policy template. It's an any-to-any connectivity type of a slice. And here we look at the different demarcation points. That is between Huawei or any node that we are taking as a PE as part of the topology, what are the demarcation points enabled. So what is the interface type, the ID, and the IP address. This is basically the information that is needed to provision the slice on the PE nodes that hand over to the CE side connectivity. And you can click on every of the node to see this information on the interface ID, interface type, and the VLAN information. Likewise, I can also see that information for every CE node here on the topology for the service. So I can click on this node. So for example, on Huawei's node, what is the interface that is peering to this node for the slice service, and what is the prefix or the IP address enabled. Likewise, the VPN service tells me what is the route target that was applied for this L3 VPN service, which is the IPv4 route targets. The next is the transport path. So this are the list of the SR policies that have been provisioned and enabled by the routers when this certain color with the request or the prefix has been advertised. So here we visualize around 14 policies with the same color 575, and I can visualize for what are the paths that these policies would take. So I can click on the Huawei node between Huawei and Ciena, and to see what is the path that this service or this slice would take between for color 575 with the intent of latency, and what is the path that it is using. And I can click on the details option to see the accumulated metric, what is being calculated, and the paths on what is the adjacency sets that this path is using. I can hover over each of them to look at the path, the flex algo information if it's assigned, and the metric type, which is latency, to say that this policy is assigned and created across this two nodes. I can visualize all the policies from Huawei. So let's say I want to say between Huawei to Juniper, what is the path that it takes, or between Huawei to Cisco, that is H50 in this case. So it's overlapping between what it goes towards a Ciena. And I can visualize these multiple paths from any vendor towards the tail ends. So for validation, we are running this test through Ixia. So as you can see from the topology, we have a bidirectional traffic, on the Keysight that is running between Cisco to Huawei, Cisco to Ericsson, and Huawei to Ericsson. There is no loss on this path, so the traffic looks good here through the Keysight. I can also validate this through another option on the policy. So let's say between Cisco and Ericsson, we are running this traffic, and I can see that what is the traffic rate that this policy is enabled for. So it's saying that it's running at a 50 megs average traffic rate. You can look at the history and see what was the traffic and what is the rate at which this traffic is learned. So it's pretty much for a controller, the operator can look at this as one-side view on the slice visualization, look at the events if there were any state changes on the policy, but the intent is there derived through the orchestration. And last part on this is through, as we described, this is through the NBI YANG models. If an operator wants to create this through any other end-to-end orchestrator that is provisioning a slice service, he can look at the slice service intent, look at the config view. I mean, this is basically the YANG model that is used to orchestrate the slice service to say between what is the ID, what is the type of the service and for which customer. And this data can be exported out, as a JSON format, and you can reuse this to create multiple slice services. So this was basically an interop test between all the vendor nodes, and I'll switch to back on the ITF draft. So we have Reza here from Ciena, who's one of the co-authors, who will talk more about the draft and the RFC.
Thank you very much, Sujay. Hello, everyone. My name is Reza Rukui. I'm the co-author of this draft. One clarification to whatever Sujay mentioned. He mentioned a couple of talks about the transport slice. At IETF, we use IETF network slice service instead of transport slice. If you want to know what is the reasons behind that, we can talk after that. But the idea here is, as you see here, we are modeling IETF network slice service, quote-unquote transport slice, from the northbound of the controller. Sujay mentioned that there is an SDN controller. From the northbound, we receive a vendor-agnostic, transport-agnostic, technology-agnostic YANG model. Operator send a request, I need connectivity, I need transport slice, or in this case, IETF network slice with some characteristic. That characteristic is shown using the SLO, SLA policies, and controller receives that request and realize it in the network. That realization is a technology specific, vendor specific, depends on which vendor is realizing using the various services, layer 2, layer 3 services, TE tunnels, SR policy, and so forth, and how the QoS is enforced. So at the end, the summary of this draft is basically defining the northbound vendor technology agnostic to define the characteristic of a network slice. Basically, it's shown the intent behind it, and using the controller, we can realize it. This draft is almost at the end of this process. We are at the working group last call, and will become RFC very soon. If you are interested to know more about that, we are more than happy to discuss it. Thank you very much.